Compound inequalities are two inequalities, compound two inequalities in the same problem. They're on the same graph, too. Compound inequalities are two inequalities in the same problem and the same graph. Compound inequalities. So there are two types of compound inequalities. There is one type called exclusive, is the first type. Exclusive inequalities. Exclusive, and the other type is called inclusive. Exclusive inequalities and inclusive inequalities. Okay. Thank you. Exclusive inequalities, inclusive inequalities. All right, let's start with exclusive. The snobs of the inequality world. Exclusive inequalities. Exclusive inequalities are two inequalities, but they're exclusive of each other, meaning that they are different from each other. They don't share anything. So they're written like this. 3x plus 2 is less than or equal to -4. That's inequality number 1. And then the word or is between them. And we have -4 plus 4x is greater than 20. So we have two inequalities in the same problem. This would be one problem. And it would say the word or between them, meaning either this one works or this one works. That's what the word or would mean. Inclusive, there are two ways of writing inclusive. Inclusive would look like, sorry, I'm trying to find a different color to write in. You could write -3 is less than or equal to 2x minus 1. And instead of the word or, it says and 2x minus 1 is less than 5. So we have exclusive with the word or, meaning either it's this one or it's this one. And then we have inclusive with the word and, which means both of them together. There is another way of writing inclusive, which is the way I prefer. -3 is less than or equal to 2x minus 1, which is less than 5. This way is the most common way of saying an inclusive. And if you look, it's the same thing. Does this problem match this inequality? Do these match? And then if I cover up this, do these match? So I just smushed them together because they can share that part. Exclusive or inclusive, right? Two types. And when you solve exclusive or inclusive, it's just regular old solving like we've been doing. Let's do our exclusive first. What do you do to solve this inequality right here? 3x plus 2 is less than or equal to -4. Minus 2. -3x is less than or equal to -6 divide by 3, divide by 3. X is less than or equal to -2. Ladies and gentlemen, why did I not flip the sign?
Because the denominator was in a...
Why, Ben?
Because you were dividing by a negative.
Correct. My coefficient was a positive value. I divided by a positive number. Even though my answer, my solution is negative, I didn't flip it because my coefficient was positive. Yes? Let's do the next one. How do you solve this guy? +4, +4. Oh, man. I did this both hours, you guys.
Oh no.
This shouldn't be here. It should be +4. Because I don't want you guys to freak out about a negative value. Or a decimal value. So pretend that says +4. My bad. So the opposite is -4. The opposite is -4. Leaving us with 4, nope, that cancels out. 4x is greater than 16. Agree? Oh, I guess I could have left it as +4. You guys, I'm having a hard day. Yeah, it's fine. Leave it this way. If I would have added 4, I would have gotten 24, which is still divisible by 4. Whatevs. Divide by 4, divide by 4. X is greater than 4. So I have 2 solutions. Do you agree? All right. For your graph of this exclusive inequality, you only have to have 1 number line. I'm going to show you this, though, on 2 number lines, or on 3 number lines. Okay? Your homework, you only have to draw the last one. But we're going to do 3 right now to talk about why it exists. So let's do the first inequality we found. And 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, -5. There's my first number line. And I'm going to graph this guy first. X is less than or equal to -2. Open or close dot? Closed at -2. Because it could be equal to -2. Do I shade up? To the right? Shade to the left. Which way? Right or left? X is less than, so I go to the left. Did the first one. Do you agree? All right, let's do the next guy. Zero, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. For my second inequality, it says x is greater than 4. Open or close dot?
Open.
Open at 4. Shading to the right or to the left?
To the right.
X is greater. Which way? My answer is both of them together. My answer is both of these on the same number line. My answer is both of these. So my answer is closed dot at -2 and shading below, and open dot at 4 shading above. This is my final answer. You do not need to draw all 3 graphs. You do not need to draw them independently, then put them on the same graph. But in our notes, we want to have them so that we can see it. All right, so an inclusive. If your graph for an exclusive looks like this, what do you think an inclusive graph would look like? Think about it. Ready? Just think about it. Imagine it. See if you're right. Gabe, do you have a question? We'll discover it. Ready? For part 2. Inclusive. Ladies and gentlemen, in inclusive, you could write each one separately and solve them independently. Or you can just solve them both at the same time. What do I do first to get x by itself?
Plus 1.
Add 1. So I'm going to add 1 over here. And I'm going to add 1 over here. I'm going to do it to both sides. I mean, could you do this guy by itself and then do this guy by itself? Sure. Negative 2 is greater than or, nope, less than or equal to. 2x is less than 6. Do you agree with my math so far? Now what do I do? Divide by 2. What's negative 2 divided by 2? Negative 1. I don't flip my sign because my coefficient was positive. X is less than 3. Okay, we're going to graph. We're going to do 3 number lines again, just so that we can see it. 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. My first inequality, if I cover it up, who can read that to me correctly? Variable first. Who can tell me what that says? Variable first. Caden, what is it?
X is less than or equal to -1.
Not less than. It's eating the x, right? It's opening towards the x, so that means the x is greater than or equal to -1. If I read it from right to left, I read -1 is less than or equal to x. But if I read it variable first, I get x is greater than or equal to -1. Right? Open or close dot? Closed at -1. Shading to the right or to the left? Because x is greater. That's my first guy, right there. Then I'm going to graph my second guy, which is right here. Zero, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Who can read this inequality to me, Seth?
X is less than +3.
X is less than 3. Open or close dot?
Open.
Open dot at 3. Shade to the right or shade to the left? To the left, because x is less than. So my solution is an open dot at 3, a closed dot at -1, and what's between them. Any number between -1, including -1, and not including 5, no, 3, any number would work. So think about this.
Positive.
What are some solutions to this problem? 1 would be a solution. +1. What else?
2.
2. 0. -1. Right?
Positive.
Is +3 a solution?
Oh no, because it's not closed off.
not a closed dot. How many answers are there to this problem?
4.
Why are there infinite solutions to it?
Because there's decimals.
Because there are
Oh, I didn't do decimals.
all kinds of decimals in there, right? However, we can't say like all of the numbers because all of the numbers don't work. Like we can't list every single number. That'd be impossible. You'd be here forever, right? But we can show it graphically. I'm going to tell you this. This is what I'm looking for. The graph, the compound inequality answer. Right? Either it's an or it's an and, correct? There is another way of writing these that you may see sometimes. My solutions to this, where my dots are, this would be -1, right? And this guy would be 3. So you know that these are your solutions. And what you put, like what people put, is they put a parenthesis if it's a closed dot and a bracket if it's an open dot. This is another way of writing this. This is not what I'm looking for. I'm just showing you this so that when you see it, it kind of maybe jogs your memory that it's something out there. All right, at your tables, I'm going to give you 2 inequalities to practice with. You guys talk about them, solve them on page 24 for practice. First one is a inclusive. Remember, I'm not looking for 3 individual graphs. I'm looking for the graph together. You try them. There's an inclusive and an exclusive.